Alrighty then. Seeing as I'm a glutton for punishment, it's 5:40 a.m. Still haven't slept. Uh, I purposely left out some data in the earlier space weather news and space weather earthquake prediction model because I didn't want to alarm everyone. I wanted to give the baby steps version for people that are not into solving existential threats and um, might freak out if they looked at the long cycles of the Earth and that there's a plausibility that we're approaching another extinction event that's not caused by humans and it's more part of the galactic long cycles and the long cycles of our star. And so now I've added the data of the book The Next End of the World by Ben Davidson and the supplement to The Next End of the World. I have his original book, the about Weatherman's Guide to the Sun. That's an academic book, and these other books are still academic, but they're not widely accepted in society, and there's probably good reason why they're not accepted, and that is that it's the end of the fucking world. um, so unless we become really highly advanced, or we go to very one of several of very few locations on the planet, or we go underground. Um, yeah, it's like plausibly catastrophic. It's the Earth catastrophe cycle. It's what it's called. And the last time it basically happens on a 6,000 year half cycle and a 12,000 ish year full cycle. So what I mean by half cycle and full cycle, so if you know anything about the sun, well, obviously it spins around and we orbit it, and it has coronal hole streams that come out at positive and negative charge, and so there's these multiple streams coming out from the sun, and they spin around, and so there's waves that come past Earth. They're positive charge, and then the next wave is negative charge. It's like peaks and troughs, but anyway, the galaxy does the same kind of thing, but because the galaxy is much bigger, what happens is this energy gets sent out through the stars at the equatorial plane, positive, negative, and that causes stars to like charge up and then go much bigger activity, like on periodically, and then that activity sends out more energy to the stars further out, and there's a term for this now called micronova. So it's not a supernova where the star actually blows up or nearly destroys itself, but it just it accumulates so much matter or gets on the outside of its shell that it changes chemistry, and then it has to shed that shell. And yeah, that kind of resonates with the North American Indians, their mythology of the sun having been a new sun several times, and this is like the fourth sun, I think, and the fifth sun is due soon. And kind of also, yeah, all of the ancient mythologies, whether it's Indian, African, Polynesian, American, Australian, they have similar mythologies where there's catastrophic times when the heavens are like arc discharging down to the earth, and the sun stops moving for several days, or it's eternal night for several days. Basically, the earth stops moving. So wherever you are on the planet, because of the magnetic fields changing in the build up between this, and Einstein was philosophizing how the continental plates would. He didn't know how they would unlock, but he philosophized how that they must unlock for continental drift to happen rapidly at different stages. And there's so many philosophies that overlap. And the Younger Dryas, currently the leading accepted scientific theory, is that impactor from the toroid meteor showers hit and impacted, but a solar micronova would eject so much crustal plasma from the star that it could congeal in the several days that it takes for plasma to get to Earth, and then also impact. So you would have impactors, you'd have solar flash, you would have unlocking of the crust, you would have arc discharges of the ionosphere from so much solar wind, where you would create new surface features. The Earth would stop for a day or more, depending on the charge of the magnetic field and which polarity it is. That would send like cyclonic winds and the oceans washing over the planet, like the Noah floods, and then all of the so there's lots of catastrophic things that would like layer on top of each other if this is actually true. And it makes reasonable sense, enough sense that we should be getting a lot of people looking at it and using blockchain to go deep into the geological record, because there's already records, but doing it again on blockchain, lots more people, because it is potentially that important. It could be the be all end all. Like, so anyway, I've added those sources now. Catastrophism and survival. Oh, I didn't mean to do that. I want to look. You can come in here, you can dive into it. Any of these are clickable: solar micronovas, atmospheric loss, major earthquakes, continental tsunamis, survival and preparation. I kind of think that we should be building underground facilities, not like the government elite, but eco-civilizations that actually enhance our surface civilizations if this turns out to be not true. I haven't put my personal designs in for that. We'll do another one on North Stradbroke Island and the civilization of sand and supercomputers of Strati and all that in a different one, because that's like my home. But for now, I'm just going to say that this stuff is well documented in here, and you can come in, look at any of it, ask questions, click on that, it'll come back to the AI. You can, like, that was the last one I clicked on. Then you can ask it questions, you can click on any of the data sets. It's all here. And now I'm just going to generate, I want a long one, so I don't want to just generate. Long one. And because it's nearly 6 a.m. and I haven't slept, I'm not even going to ask it anything. The last one it did was like an hour, and that was without the really nasty stuff. So, yeah. I'm signing out, and I'm going to just tack this on. I'll put a song in there maybe from my new album, Starseed Code, From Aura to Infinity, and we'll see what Notebook LM is. And in the link in the YouTube, you'll be able to come in and search this data. So All right. Hooroo.
What if the very ground beneath our feet, the air we breathe, and even our own minds are far more deeply intertwined with the distant cosmos than we ever imagined? We live on a dynamic planet constantly interacting with immense, invisible forces from space.
That's right.
Today, we're going to embark on an extraordinary deep dive into how cutting-edge science is revealing these profound, hidden connections.
Yeah, and challenging what we thought we knew about Earth and our place in the universe.
Exactly.
We're stepping into a fascinating realm, really, where ancient wisdom and modern scientific breakthroughs seem to converge.
Right.
Our sources for this deep dive are an extraordinary collection, I have to say. They fundamentally challenge our conventional understanding of Earth, space, and even ourselves.
So what are we looking at?
Well, we'll be exploring scientific revelations that suggest ancient insights might hold surprising truths.
Okay.
And perhaps even more excitingly, how new technologies are being developed not just to observe, but to help us truly understand, visualize, and even prepare for these insights on an unprecedented scale.
And what a captivating stack of material we have for you today. It's truly a treasure trove. We've received everything from highly detailed scientific papers on solar terrestrial physics and galactic dynamics
The really technical stuff.
to intriguing blueprints for immersive virtual reality environments and even historical accounts of profound catastrophic events that have shaped our planet.
A real mix.
It is. Our mission, as always, is to extract the most crucial nuggets of knowledge from these diverse sources, explore the why behind these often surprising facts,
Get to the bottom of it.
and ultimately understand what this all means for you, our curious listener. We're going on a journey, quite literally, from the sun's subtle whispers echoing down to Earth, out to the Milky Way's grand, majestic pronouncements, and then back again, right to how we can adapt and thrive here on our home planet.
So let's begin by grounding ourselves, if you will, with Earth's profound interconnectedness.
Okay.
Starting with our closest and most influential star, the sun. It's often seen as, a constant, unwavering source of light and warmth.
Yeah, the steady backdrop.
But our sources paint a far more dynamic picture.
When we think about the sun's influence on Earth, our minds usually go straight to its light and heat, what scientists call irradiance.
Right, the basics.
But what's truly eye-opening from our sources is that traditional climate models, the ones many of us are familiar with, seem to have a significant blind spot.
A blind spot. How so?
They often, and quite dramatically it seems, underestimate the sun's actual, much broader role in our climate system.
Yeah.
New findings demonstrate that the direct solar forcing the immediate impact of the sun's energy is actually double what these models typically allow for.
Double. Wow.
Yeah. This requires an equal amount of indirect forcing beyond just its brightness. It suggests there's a lot more going on than just the sun's visible light.
This is a critical point. This finding directly challenges mainstream views that frequently attribute nearly all modern climate change solely to human greenhouse gas pollution.
Right. The standard narrative.
Our sources highlight a remarkable oversight. Many studies, especially those in the climate modeling community, fail to properly incorporate crucial solar particle forcing datasets.
So they're missing a key piece of the puzzle.
It appears so.
Huh?
One source goes as far as to state a failure of 99.9% of similar papers to fully apply well-known solar particle forcing datasets and Earth's weakening magnetic field into their analyses.
99.9%. That's a huge claim.
It is. And it isn't just a minor detail. It suggests a significant systemic gap in how much of the current climate literature frames the global climate picture. The sun's influence isn't just about its light, it's about its entire energetic output.
So it's not just the familiar light and heat, the irradiance, but also these invisible streams of particles that are profoundly impacting Earth.
Exactly.
We're talking about phenomena like high-energy cosmic rays and the solar wind, a constant flow of charged particles from the sun. These aren't just responsible for pretty light shows like the Aurora Borealis and Australis, as beautiful as they are.
Though they are beautiful.
They are. But our sources confirm they have far more profound global effects.
What's truly fascinating here is the energetic coupling between the sun and Earth. It's not a simple one-way street.
Okay.
Solar wind energy, those charged particles, can actually penetrate electric fields through our ionosphere. That's the part of our upper atmosphere that's ionized by solar radiation, reaching even low latitudes.
Low latitude, so not just the poles.
Correct. And a key factor in this penetration is its intimate dependence on the magnetic field and the magnetic reversals within the solar wind itself.
Magnetic reversals in the solar wind.
Yes, these magnetic reversals occur when the sun's vast current sheet sweeps past Earth, which happens surprisingly often, roughly every 5 to 10 days.
Every week or so.
Pretty much. They strongly impact equatorial electric fields, often preceding or happening concurrently with auroras and the onset of geomagnetic storms.
Huh.
Historically, the subtle correlations between these solar climate factors have been incredibly difficult to spot in older data and model projections.
So why was that?
This is largely due to something called hemispheric asymmetry of ionospheric effects.
That sounds like a very specific scientific challenge. Can you break down what hemispheric asymmetry means in this context and why it made these connections so hard to see?
Absolutely.
Okay.
Imagine trying to hear a quiet whisper in a very loud room, but the sound is different depending on which ear you're using.
Okay.
Hemispheric asymmetry means that our upper atmosphere, the ionosphere, reacts differently to solar inputs in the northern hemisphere versus the southern.
So it's not uniform.
Exactly. This uneven response creates a kind of noise or distortion in the data. Because the effects weren't uniform across the globe, it was incredibly challenging to discern the more subtle but globally significant solar climate signals from the background variability in older data sets. It obscured the larger pattern.
Right, makes sense. So once that solar wind energy impacts rapidly interacting with the ionospheric layers, it creates a very fast influence, similar to what we see with solar flare X-rays. And this is where Earth's global electric circuit takes over, acting as a crucial intermediary. This circuit connects everything from the ground to the ionosphere and back.
Like the planet's wiring.
Sort of, yeah. But here's what's truly mind-bending. A major discovery on Jupiter actually solved a 50-year mystery of its incredibly hot atmosphere.
Jupiter. What happened there?
Auroral energy, similar to our own northern and southern lights, is beamed not just into the poles, but surprisingly, directly towards Jupiter's equator, heating it via infrared energy.
Towards the equator. That's unexpected.
Very. And our sources reveal that, astonishingly, this exact mechanism may be at work on Earth, too.
That's right. 2 very recent studies have solidified this idea of equatorward traveling waves on Earth.
Equatorward traveling waves.
These are not typical weather waves, but powerful disturbances that transport auroral energy from high latitudes, where the auroras typically occur, down to lower latitudes through the thermosphere. That's an even higher layer of our atmosphere.
Okay, higher up.
This occurs after the rapid penetrating fields during geomagnetic disturbances. This process creates a significant disequilibrium of density, energy, particle velocity, and radiation.
A big imbalance.
A huge imbalance where energy literally leaks equatorward through the tenuous conductive atmosphere due to plasma pressure.
Leaks, like it's spilling over.
Think of it like a dam breaking. When the solar wind slams into our magnetosphere, it creates such an intense imbalance of energy and particles in the upper atmosphere that this energy literally flows downwards and sideways, pushing towards the equator through the very thin electrically charged air.
Wow.
It's a fundamental energy transfer mechanism that's only recently being fully understood for Earth, showing our planet isn't just a passive receiver, but an active participant in these cosmic energy transfers.
This brings us to Earth's primary defense system against these energetic solar inputs, its magnetic field.
Or shield.
Exactly. And here's where it gets truly consequential for all of us. Our sources clearly indicate that Earth's magnetic field is continuously and quite rapidly weakening.
Continuously weakening.
Yes. It's currently estimated to be 20–25% weaker than its peak strength, with a notable 10% loss already observed by the year 2000 and a further 15% loss by 2010.
That sounds significant. 25% weaker now.
That's what the sources state.
This diminishing field strength is incredibly significant because it profoundly enhances any negative biological impacts from solar forcing, making our planet increasingly vulnerable to space weather.
So less protection.
Much less. A weaker field means that even lesser solar activity, events that might once have been considered minor, can now produce impacts historically only seen with much stronger events. And this isn't just a gradual drift. The magnetic pole acceleration isn't just continuous, it includes a global geomagnetic jerk that occurred in 2019-2020.
A geomagnetic jerk? What on earth is that?
A geomagnetic jerk is a sudden and abrupt change in the Earth's magnetic field's rate of change over a very short period, like a quick acceleration or deceleration.
Okay.
Our sources pinpoint the magnetic poles tracking towards a meeting point between Sumatra and Java, Indonesia.
Indonesia? That's quite a shift.
It is, and this critical shift is actually leading to the construction of a brand new magnetic observatory there, specifically to monitor these accelerating changes in real time.
They're building an observatory just for this.
Seems so. It's a clear signal that something fundamental is happening within Earth's core.
And this brings us to some fascinating claims that directly challenge widely accepted notions about climate change and Earth's warming.
Okay, like what?
Our sources introduce phenomena like Dansgaard-Oshia or DO events and Bond events.
Right, I've heard of those. Natural climate cycles.
Exactly. Well-studied natural climate occurrences that demonstrate modern warming is, in the grand scheme of Earth's history, apparently nothing extreme.
Nothing extreme compared to these past events.
That's the argument. The key fact here, which demands our attention, is that these events show repeating temperature spikes of 5 to 8 degrees C in polar regions.
5 to 8 degrees Celsius, that's enormous.
It is. But crucially, these aren't gradual changes over centuries. They occur over incredibly short periods, just 30, 40 years.
Wait, 30 to 40 years for that much warming?
Yeah. Which, as the sources point out, dwarfs the modern warming of approximately 1–2 degrees C over the last 150–200 years in both its pace and its severity.
That really puts it in perspective.
It does. What's even more fascinating here is a built-in cooling correction mechanism described in the sources.
The self-correction, how does that work?
Melting polar ice not only cools and freshens the oceans, obviously,
Right.
but it also surprisingly shuts down heat transport towards the poles and, counterintuitively, reduces CO2 sensitivity.
Reduces CO2 sensitivity. How?
The sources don't fully elaborate on the mechanism, but the implication they draw is profound. They state, the more of the mainstream global warming we have, the less CO2 matters in the long run.
That's a very counterintuitive claim.
It is, and these major global heating events occur roughly every 1,500 years, followed by significant cooling, suggesting a natural, powerful rhythm to Earth's climate.
A 1,500-year cycle.
So we're talking about these profound, long-term cosmic cycles influencing Earth's climate on scales of thousands of years. It suggests a much deeper, almost rhythmic interaction with our solar system and beyond.
Absolutely.
Our sources dive deep into what's known as the solar Heinrich-Bond cycle, a specific, powerful cycle that repeats over 1,500 years with a major harmonic or subcycle at 6,000 years.
Okay, so nested cycles.
Exactly. It's remarkably well understood, documented over the last 45,000 years, and even cataloged back beyond 120,000 years ago.
There's a clear and compelling connection between Earth's magnetic field and these cycles. Geomagnetic strength changes align directly with Heinrich events.
Heinrich events, those are the big iceberg discharges, right?
Correct. Massive discharges from the Laurentide ice sheet into the North Atlantic, indicative of dramatic climate shifts. And it's been approximately 6,000 years since the last major Heinrich event.
The length of the major harmonic.
Precisely. What's telling is that we're currently observing our descent into the next event on Holocene geomagnetic charts, meaning the patterns of Earth's magnetic field are mirroring past periods that led to these grand events.
So the magnetic field is showing signs consistent with the lead-up to these past events.
That's what the charts suggest. The sun's influence over geomagnetic activity is now considerably evidenced for both the 1,500 and 6,000-year cycles. For instance, modern-day geomagnetic variation began surging in 1859.
1859, that date rings a bell.
It should. It's the exact same year as the Carrington event, the last major solar flare recorded.
Wow. That is a striking alignment, not just a coincidence, the sources suggest.
The sources strongly argue against coincidence. The alignment of the surge in geomagnetic activity with one of the most powerful solar flares in recorded history strongly suggests a direct causal link between intense solar output and Earth's magnetic response, fitting perfectly within these longer cycles.
Okay, that's a powerful correlation. But what about the more immediate observable effects? Are there any daily phenomena that are already signaling these cosmic influences right here on the surface?
Good question. Our sources highlight a surprising and increasingly visible indicator: lightning.
Lightning, really?
Right. It's not just becoming more numerous globally, but records are being set, particularly in the Arctic, where solar forcing that direct energy input from the sun is strongest.
More lightning in the Arctic?
And here's a truly surprising fact that emerged in just the last 2 years. 2 new forms of lightning, including these incredible mega flash events resembling massive electrical discharges from Earth itself, have reportedly been discovered.
New forms of lightning, like fundamentally different.
Apparently so. This isn't just an increase in frequency. It suggests something profound is truly changing in our atmosphere's electrical properties.
Okay.
Strong lighting from below perturbs the ionosphere, just as space weather perturbs it from above, creating more electrodynamic atmospheric conditions.
More electrically charged, you mean?
Exactly. Think of it as the atmosphere becoming more electrically charged and responsive. This amplifies weather changes and significantly increases the biosphere's vulnerability, including a noticeable increase in lightning-driven wildfire activity.
Ah, the wildfire connection.
The literal feedback loop between Earth and space.
The sun's pervasive influence doesn't stop there, does it? Our sources delved into hundreds of studies that have explored the profound impact of solar activity on precipitation intensity,
The rainfall, yeah?
including the kind of extreme rainfall and flooding phenomena we're increasingly seeing worldwide.
One new study in particular, highlighted in our sources, shows a very close correlation between major flooding events in Europe and solar proton flux. That's the stream of high-energy protons emitted by the sun.
So you can track solar protons and predict floods in Europe.
This study suggests it's possible with remarkable accuracy. It makes it possible to successfully predict these destructive events by simply monitoring the high-energy proton bombardment of Earth.
That's incredible predictive power.
It is. Even more broadly, historical hydroclimate changes, like those seen in the Chinese monsoon over thousands of years, are tied directly to fluctuations in Earth's geomagnetic field characteristics.
So the magnetic field affects rainfall patterns long term.
Directly. This direct link influences regional rain and temperature patterns on scales stretching back millennia, showcasing the sun's deep, long-term grip on our weather systems.
This raises an important question that many people probably wouldn't even consider. Is there a direct link between solar activity and earthquakes?
The earthquake question.
It sounds almost like something out of a science fiction novel, a grand cosmic influence on the very ground beneath our feet, but our sources confirm a clear correlation.
Yes, our sources confirm a compelling correlation between periods of high solar activity and increased seismic activity, suggesting that geomagnetic disturbances caused by solar activity may actually influence tectonic stress.
How strong is that link?
What's particularly fascinating here is that higher frequencies of earthquakes, specifically those magnitude 5 and greater, are observed during the decay phases of solar cycles and the rising phase of solar cycle 24.
Specific phases of the cycle.
Yes. For a concrete example, the massive M9.1 Japan earthquake in 2011 was notably preceded by a series of high-speed streams from an enlarged coronal hole during what was otherwise a weak solar cycle.
The Japan quake. Wow.
Furthermore, rigorous statistical tests in our sources further confirm a significant negative correlation between sunspot number and global seismic energy release, especially during solar cycle decay phases.
Meaning fewer sunspots often coincide with more powerful earthquakes globally.
That's the statistical finding, yes.
And it gets even more specific, talking about precursor signals that could warn us before an earthquake strikes.
Indeed. Our sources point to ultra-low frequency, or ULF, wave activity specifically. Very low frequency waves vibrating less than 1 millihertz, so less than once every 16 minutes or so,
Very slow waves.
being observed before significant earthquakes, such as the Loma Prieta earthquake. What's crucial is that these waves are well correlated with solar magnetospheric effects, specifically a type of wave called Alfvén waves.
Alfvén waves. Can you explain those briefly?
Sure. ULF waves are essentially very slow, large-scale magnetic pulsations, like giant invisible ripples in Earth's magnetic field. Alfvén waves are a specific type of ULF wave that propagate along magnetic field lines within plasma, the charged gas that makes up most of space.
Okay.
They originate from the sun's activity, like solar flares or coronal mass ejections, or from disturbances further out in the solar system. When these waves reach Earth's magnetosphere, our planet's magnetic shield, they can transfer significant energy deep into our planet's interior.
Energy penetrating deep inside Earth.
Yes, this energy subtly influences the stress on tectonic plates, potentially acting as both earthquake precursors and agents.
Precursors and agents, meaning they don't just signal it, they might help cause it.
Potentially, yes. They might not just signal an impending earthquake, but actively contribute to triggering one by nudging stressed fault lines over the edge.
Given all this intricate interconnectedness, it's absolutely critical to improve our forecasting capabilities, especially for something as significant as coronal holes.
Actually.
Our sources highlight what's been a significant gap in space weather forecasting: the absence of robust predictive models for these coronal holes.
Right. Coronal holes are cooler, darker regions on the sun's outer atmosphere where magnetic field lines open up, allowing high-speed solar winds to stream out into space. These solar winds are a primary cause of geomagnetic disturbances here on Earth.
So predicting them is key.
Absolutely. Our sources detail a pioneering approach that uses advanced computer vision techniques, teaching computers to detect these coronal hole regions and accurately estimate their dimensions from Solar Dynamics Observatory, or SDO, imagery.
Using AI to watch the sun.
Essentially, yes. This project leverages long short-term memory, or LSTM, deep learning models. These are sophisticated AI networks particularly good at recognizing patterns and sequences of data over time.
Okay.
They analyze trends in the SDO imagery to predict coronal hole dimensions over a 7-day span.
A week's notice.
That's the goal. The significance of this is immense. It provides invaluable lead time for preparations against potential space weather events that can cause widespread power grid failures, disrupt communication systems, and damage orbiting satellites.
Huge implications for infrastructure.
Massive. To ensure the robustness and reliability of this predictive capability, the model was meticulously trained on a full decade of solar data, encompassing an entire solar cycle to capture the full gamut of solar activities. This allows for much more proactive space weather management.
Now let's zoom out even further and look at the bigger picture. When we think about Earth's place in the cosmos, our sources don't just stop at the sun.
Doing galactic now.
We are. They dive into the profound realm of galactic astrophysics. Here, they confirm the existence and fundamental nature of the galactic current sheet, or GCS.
And GCS, okay, what is that exactly?
Yeah.
If we connect this to the bigger picture, the GCS is a truly massive, undulating sheet of plasma and magnetic fields that permeates our galaxy.
A giant sheet across the galaxy.
Pretty much. It's proposed as a fundamental trigger for cyclical shifts within our entire solar system, and crucially, for Earth's own long-term catastrophe cycle.
The catastrophe cycle trigger.
That's the hypothesis.
Yeah.
Our solar system is currently in the process of moving from the positive southern galactic magnetic sector into the negative northern galactic magnetic sector. An immense journey.
You're crossing this sheet.
We are. To give you a sense of scale, imagine ripples in this sheet that are approximately 225 light-years tall, with a wavelength or sequence about 50 light-years wide, as noted by Dr. Jim Cordes at Cornell.
That's unbelievably huge.
It is. What's truly mind-bending here is the direct evidence of a plasma pressure front now surrounding our solar system in the very near interstellar medium.
A pressure front. Like a bow wave.
Something like that. This bolsters the concept that the observed changes at the sun, in interplanetary space and on other planets, are in fact related to the arrival of this galactic sheet and its associated magnetic reversal.
So the changes we see on planets could be linked to this galactic crossing?
That's the idea. Further evidence comes from galactic radiofilaments, which are equally spaced, implying they are part of this larger magnetic system. These vertical fields connect the interstellar magnetic field running through the GCS with the poloidal magnetic fields, the large-scale pole-to-pole fields of the galactic center.
It paints a picture of our solar system not as an isolated entity, but as a small ship sailing through vast, magnetically charged cosmic waters.
A very apt analogy, constantly interacting with them.
And speaking of large-scale galactic structures, there's the famous Radcliffe wave in the galaxy, a massive wave-like structure of gas and dust.
Right, discovered relatively recently.
It was initially thought to be a simple ripple, but was recently shown to be part of a much larger vertical kinematic oscillation, which our sources argue is the very same rippling GCS.
So Radcliffe wave is the galactic current sheet, or part of it.
That's the connection being made. This immense wave extends radially outward from the galactic center, mirroring, on a galactic scale, how the solar system's own current sheet works.
Fascinating symmetry.
One intriguing hypothesis for its sustained nature across the vastness of the galaxy is what's called a vertical velocity dipole.
A vertical velocity dipole.
Which, as the source puts it, sounds like a wonderfully creative name for the galactic magnetic reversal itself, riding within the central plane of the system.
Ah, so the reversal is the dipole.
It implies that this colossal wave is not just a passive structure, but an active, propagating magnetic phenomenon that influences everything it passes through, including our solar system.
The real insight here is how deeply interwoven our local environment is with the cosmos. It suggests that events happening millions of light years away aren't just distant phenomena, but part of a universal electromagnetic symphony that echoes all the way down to our sun and even Earth. It forces us to reconsider the traditional isolation of planetary science and embrace a truly cosmic perspective of our existence.
This raises an incredibly important and, frankly, a bit unsettling question. What would a full system galactic magnetic reversal look like, especially if combined with powerful outbursts from the galactic core?
Our sources explain that such an event at the galactic scale would strikingly match the Sun's own 11-year magnetic reversal cycle and its concurrent uptick in solar flaring.
Like a scaled-up version of the sun's cycle.
Exactly. It would also align with Earth's mega-flash lightning events and increased volcanic activity during geomagnetic reversals. The discovery of such an event at the galactic scale is incredibly telling for the scalability of these electromagnetic systems.
Same physics, different scales.
Precisely. It suggests that the same fundamental principles governing our sun's behavior and Earth's response might apply to the galaxy as a whole. The flaring from the galactic nucleus during its reversal is exactly what's expected to occur at our sun as well, a scaled-down echo of a much grander cosmic event. Consider the sheer improbability factor of witnessing all these new, groundbreaking discoveries, from galactic structures to solar physics and Earth's geological changes in just the last few years.
It does seem like a lot is converging right now.
It really does. They actually outnumber the total number of discoveries relevant to modern catastrophism compiled over decades of published literature. It's almost as if, as the sources suggest, all is being revealed in the end, indicating a crescendo of understanding.
The complexity of galactic dynamics is truly astounding, and our sources delve even deeper into it. They analyze what's known as the LZOVR wave, which is a pattern in the phase shift amplitude relative to the angular momentum component.
Okay, that sounds quite technical. Using Gaia data.
Yes, using data from the Gaia DR3 mission, which meticulously maps billions of stars in our galaxy, and controlled numerical experiments.
And the goal.
The goal here is to precisely differentiate whether this wave originates from internal perturbations within the galaxy itself, like a steadily rotating central bar structure and two-armed transient spirals.
So, things happening inside the galaxy.
Or from external influences, such as impacts from satellite galaxies.
Internal versus external causes. What's the verdict?
Well, while requiring caution due to the current simplicity of the simulations, the comparison suggests that internal perturbations are more likely to be the dominant driving force.
Interesting.
The characteristic peak related to the bar's 2.1 outer Lindblad resonance, that's a specific type of gravitational resonance that affects star orbits.
Right, influencing spiral arms.
Persists regardless of the evolution phase of the transient spiral arms. This particular pattern doesn't align with what would be seen from external satellite impacts.
So the evidence points inward for now.
For now, yes. This highlights the ongoing, meticulous scientific efforts to unravel the complex internal movements of our own galaxy, seeking to understand the deep, fundamental forces that shape it. Shifting back to Earth, the study of horrendous events that punctuate the normally calm and benign Earth, a field known as catastrophism.
Catastrophism, yes. It used to be quite controversial.
It did. But it has seen an incredible resurgence since 2018. New revelations are now unifying previously disparate scientific fields like geology, astrophysics, and even archaeology.
It's fascinating how this scientific resurgence finds echoes in ancient human experience. Ancient myths and religions across the globe vividly describe past and even future catastrophes.
Like the flood myths.
Exactly. Think of stories from Peru and South America of the sun standing still or setting in the wrong place, or a long night described in legends from Malaysia and Sumatra. The Bible and Egyptian legends speak of a black sun, while Norse Ragnarok tells of Earth sinking into a roaring ocean. Even Zoroastrianism speaks of the sun being more unseen and spotted, with days and years shortening. These aren't just quaint stories. Our sources highlight how these historical accounts are finding surprising parallels and even scientific confirmation in modern inquiry.
Suggesting a collective memory of profound planet-altering events.
That's the intriguing possibility, yes.
The evidence from the past is incredibly compelling, supporting these ancient narratives. Beyond gradual erosion, geologists are finding what are called surge deposits.
Surge deposits.
Vast layers filled with thousands of animal bones, often from various species mixed together, suggesting instant, catastrophic devastation.
Not a slow accumulation.
No. We also see rapid deposits and incredible morphological changes in sediment layers that point to sudden, massive energetic events, not slow processes.
And that's just the start. Our sources reveal vast, deep-sea canyons running off continental shelves that are proposed as runoff features from when oceans were, quite literally, torn from their beds.
Torn from their beds. That's dramatic phrasing.
It is. Then there are the infamous frozen mammoths, found preserved so quickly that the food in their mouths and stomachs hadn't decayed.
The ones flash frozen mid-meal.
Exactly. Indicating extremely rapid, instantaneous environmental shifts far beyond anything a gradual climate change could explain.
Right.
There's also compelling evidence of impactor microtectites, those tiny glass beads formed from molten rock flung into the atmosphere during impacts and air bursts, similar to the 1908 Tunguska event, linked to some of these cyclical catastrophes.
So impacts are part of the picture, too.
They seem to be. What's more, in the late 1940s, Major Maynard E. White's expedition to map the Arctic uncovered crucial core evidence. Not just the magnetic North Pole, but its instability, and startling proof of alternating periods where the polar region had a hot, tropical climate before suddenly becoming frigid.
Tropical Arctic, then suddenly frozen.
That's what his core samples showed. His records and the subsequent Pentagon meetings about these discoveries were quickly classified.
Classified? Why?
Indicating the profound implications of his findings, perhaps.
And speaking of classified information, it's truly remarkable that a declassified CIA file and the book The Adam and Eve Story, published way back in the 1960s, but rediscovered in 2018.
The Adam and Eve story. I remember the buzz around that resurfacing.
Right. It compiled much of this evidence from Major White and others. Its author, Chan Thomas, definitively settled on galactic magnetism as the trigger for these massive crustal shifts.
Galactic magnetism again.
Even if his understanding of galactic magnetism was slightly off at the time, his work provided crucial clues and pointed future researchers in the right direction, connecting these seemingly disparate phenomena.
Building on this foundation, our sources present a truly fascinating and comprehensive concept to tie all this evidence together. The solar micronova hypothesis.
A micronova from our sun.
That's the proposal. This proposes that our own sun experiences a recurrent nova event, a sudden, powerful burst of energy occurring on an approximate 10,000 to 15,000 year cycle.
A 10-15,000 year cycle.
Yes. And this cycle actually fits quite well within the realm of known recurrent nova events observed elsewhere in the galaxy.
So it's not unprecedented for stars like ours.
Not necessarily. What's truly fascinating here is that this solar micronova hypothesis is proposed as the only way to simultaneously explain all the diffuse evidence we've discussed.
The only way. That's a strong claim.
It is. This includes the isotopic signatures found in ice cores and sediments, such as a clear nova-level spike around 12,000, 13,000 years ago, indicating a cosmic ray bombardment consistent with the solar outburst.
Right, the Younger Dryas period, roughly.
And the seemingly coincidental impactors like microtectites and air bursts, which could be related to material ejected during a solar event or impacts on Earth caused by the chaotic environment induced by such an event.
So the trigger for this cyclical event on our sun, which would be truly devastating for Earth, could be its crossing of the galactic current sheet, that immense cosmic structure we discussed earlier.
That's one leading hypothesis.
This crossing could cause either an accretion of dust and gas onto the sun, essentially feeding it, or an electromagnetic disruption of its solar wind outflow, fundamentally altering its dynamic.
It's important to understand that stars can and do micronova recurrently, and surprisingly, they don't necessarily need a binary star partner, which is often a factor in other types of nova.
So a single star can do this.
Yes. Instead, a simple change in their local space environment or their own internal output power can induce it. For example, the sun could be triggered by shock waves from other supernovae, passing through dense molecular clouds, or even interacting with the spiral arms of gas and dust density within the galaxy.
So various cosmic triggers are possible.
Exactly.
Yeah.
These are all natural, powerful cosmic phenomena that could provide the necessary stimulus. One source uses a particularly vivid analogy to describe how scientists sometimes approach these truths.
Go.
It's like a starving gorilla strayed off through a coconut field, and all he sees are brown rocks because he had no idea food could look like that.
Huh. That's quite an image.
It is. It describes how scientists, while seeking the truth, can be hopelessly without most of the proper tools to finish the job when confronted with the enormity of these interconnected electromagnetic phenomena because their existing paradigms don't allow them to see the full picture.
This brings us to how these grand cosmic forces might actually affect our planet's very physical structure, specifically what our sources describe as the unlocking of Earth's crust.
The crust unlocking.
The great waves, often described in ancient lore, those biblical deluges and flood myths, find a truly surprising scientific explanation in our sources: the unlocking of Earth's rigid crust from its underlying mantle at the low velocity zone, which is essentially the crust-mantle boundary.
So the crust slips over the mantle.
That's the idea. This phenomenon is theorized to occur due to intense thermal or electromagnetic modulation.
Heat or electricity causing the slip.
This specific mechanism provides a powerful explanation for the cyclical deluges that appear throughout Earth's history. And it also explains why magnetic pole positions seem to consistently return to similar places over eons, as well as the perplexing alternating layers of tropical and polar fossil layers found by Major White's team in the Arctic.
It connects a lot of dots.
It does. It's crucial for listeners to understand that these great waves are not typical tsunamis.
Right, not the Hollywood wave.
No. Instead of imagining a wave hundreds of feet high that crashes instantly, think of it more like a fluid dynamic super high tide.
A super high tide. Explain that.
To put it in perspective, if Earth's rotation were to suddenly stop in 1 hour, the oceans would only decelerate by about 17 miles per hour per minute. This wouldn't create a crashing wall of water,
Okay.
but rather water levels would rise steadily over a long period, perhaps a foot per minute over an entire day, gently but relentlessly pushing inland through valleys and low-lying areas, not cresting in a massive, instantaneously destructive wall.
So a slow, inexorable rise.
Well,
More insidious in a way.
exactly, a far more pervasive and long-lasting inundation. And here's where science gets hands-on, bringing these abstract ideas into the lab with astonishing results. Billy Yelverton's remarkable experiments.
Yelverton. What did he do?
He demonstrated how even non-kinetic electromagnetic interactions, meaning no physical force, just electricity and magnetism, can cause olivine, which is the most abundant mineral in Earth's upper mantle and also found in the crust,
Olivine. Right.
to actually translocate or move from one place to another.
Just with electricity. How?
That's right. The results were incredible. Simply supplying an electric current to olivine crystals and then discharging it caused the crystals to literally fly or levitate and move within the experimental setup.
Wow. Levitating minerals.
This has profound implications for understanding phenomena like mantle heaving, the large-scale upward movement of material in the Earth's mantle, and the very unlocking of the crust.
A mechanism for the slip.
Possibly. His experiments also astonishingly showed that water translocation, or movement, explicitly follows electric currents, with the effect increasing dramatically with salinity.
Water follows the current too, especially salty water.
Yes. What's even more astonishing is that he could get water to push up against gravity on rock layers,
Water moving against gravity.
which suggests that the vast quantities of water locked within the Earth's mantle, estimated to be more than in all surface oceans combined, could play a dynamic role in these processes.
The mantle water. That's huge.
These experiments provide a tangible physical basis for how the electromagnetic fields, amplified during intense solar events or geomagnetic excursions, could directly influence Earth's internal structure, leading to massive crustal movements and global waves. It suggests our planet is far more electrically responsive than we previously understood.
It really changes the picture of geology.
If we connect this to the bigger picture, our sources indicate that the profound changes observed on other planets throughout our solar system also serve as compelling, independent evidence for this grand galactic story.
Ah, the other planets are showing signs too.
It's not just Earth that's affected. Exactly. Consider Venus, which is experiencing surprisingly faster winds and has baffling phosphine signatures in its atmosphere.
Venus heating up.
Or Jupiter, with its higher X-ray energy events and anomalous behavior of its iconic Great Red Spot. Saturn experienced an early superstorm, a phenomenon scientists didn't expect to see for decades.
Saturn's storm was early. Interesting.
Uranus and Neptune are showing unprecedented storm and auroral anomalies, and even Pluto, far out on the solar system's edge, has seen its thin atmosphere mysteriously collapse.
Pluto's atmosphere gone. Wow.
These widespread planetary changes align remarkably well with the theory of our solar system encountering the galactic current sheet.
It's like celestial dominoes falling across our cosmic neighborhood.
That's a good way to put it. Furthermore, observations of nearby stars, such as AD Leonis, also show anomalous activity, providing even more evidence that the progression of the galactic sheet's impact is sweeping through our stellar neighborhood, affecting stars and planets alike.
So it's not just our solar system, but our neighbors too.
Seems that way. Beyond the dramatic environmental and geological effects, our sources detail something very personal to each of us. Space weather profoundly affects human biology.
The biological connection. Yeah.
It's truly surprising, even a little unsettling, how direct some of these correlations are impacting our health and well-being.
The research compiled in our sources is quite stark. It details an increased risk of death from acute myocardial infarction with ischemic heart disease, a serious heart attack,
Heart attacks linked to solar flares.
beginning precisely at the moment of a solar flare and lasting for 3 full days after a geomagnetic storm. That's what the data shows.
Days after.
We also see significantly decreased basal metabolic rate and oxygen consumption conversion during solar storms or enhanced geomagnetic activity.
Meaning our bodies become less efficient at processing energy and even breathing.
Essentially, yes. Prenatal exposure to increased solar and geomagnetic activity has been shown to increase the risk of preterm birth.
Preterm births.
And shockingly, increased cosmic ray activity directly coincides with increases in sudden infant death syndrome, or SIDS.
SI, so that's heavy.
It is. This field, though often overlooked, is far more developed and mature than most people realize, unequivocally confirming the biological and physiological parameters, including severe reactions and mortality, are intimately related to space weather, geomagnetic conditions, cosmic rays, and the interplanetary magnetic field. We are truly creatures of the cosmos.
And it's not just physical, the psychological effects are equally compelling and perhaps even more insidious given their nature.
That's right. Emotional instability, cognitive and sensory diminution, essentially, a decrease in our ability to think clearly and perceive the world around us.
Brain fog, almost.
I could say. And other severe negative psychological outcomes are more common under geomagnetic storm and excess cosmic ray conditions. This scenario becomes imaginatively horrifying, as one source puts it, during a full geomagnetic excursion where the field weakens even further and becomes chaotic.
Imaginatively horrifying.
It truly tests human resilience on multiple levels. However, our sources offer a profound and deeply insightful concept here: the placebo effect.
The placebo effect, how does that fit in?
It's highlighted as a powerful, almost magic tool for self-protection against these impacts. It's described not as a trick, but as the overruling of the laws of science based on a thought in your mind.
A thought overruling physics.
Suggesting that a simple, focused thought can, in some cases, reverse outcomes dictated by chemistry and physics. This encourages you, our listener, to consciously use this inherent power in a positive way for your own mental and physical well-being, especially when confronted with these powerful cosmic forces.
Mind over matter, in a very real sense. So, with all this incredible interconnected science laid out, what does this all mean for us in practical terms? How can we leverage cutting-edge technology to gain deeper insight and prepare for these profound cosmic rhythms?
The practical side.
Our sources reveal a groundbreaking initiative designed precisely for this purpose, the Space Weather News Hub.
The News Hub. Tell us about it.
This hub is envisioned as an ambitious educational program, integrating the power of generative AI and multimodal large language models, the same kind of AI behind systems like ChatGPT, but far more specialized.
AI for space weather education.
To inform and engage a diverse global audience about space weather. This is especially crucial as we approach the upcoming solar maximum, the peak of the sun's activity cycle.
Good timing.
It's designed to provide not just raw data, but digestible, contextualized information to everyone. And it's built on a remarkably robust real-time data pipeline and integration system.
Real-time data. From where?
The hub is designed to ingest live data from a wide variety of scientific sources, and I mean live. This includes direct feeds from NOAA and NASA, capturing everything from solar wind speeds, solar flares, and sunspot numbers.
The standard space weather metrics.
To ground magnetometer indices like the KP index, which measures geomagnetic activity, ionospheric data via total electron content maps, and even remote sensing data such as INSAR ground deformation for precise ground movement and comprehensive earthquake catalogs from the USGS.
Wow, pulling in seismic data too. That's comprehensive.
It is. This real-time streaming is built on a robust back-end infrastructure, utilizing advanced tools designed to handle massive influxes of data efficiently and reliably.
And what happens to the data then?
A crucial data processing layer then runs continuous analytics in real time. It computes derived metrics, detects anomalies like sudden solar wind shocks, and, fascinatingly, correlates different data streams, for instance, linking specific solar events with observed earthquakes.
Real-time correlation. That's powerful.
Crucially, it triggers immediate alerts if, say, a coronal mass ejection, a powerful burst of solar plasma, is detected heading toward Earth. This entire system is designed for speed and accuracy.
So instant warnings.
This processed data, once it's been cleaned and analyzed, then flows directly into the Unity application, which is the powerful engine that powers the immersive VR experience.
Ah, the VR component.
It pulls this live data through various mechanisms, including periodic web API polling for less critical data, and high-speed WebSockets for time-sensitive alerts, ensuring you get the most up-to-the-minute information.
To ensure smooth, high-performance visualization in the VR environment, the Unity application maintains a local cache of recent data.
Keeps it running smoothly.
Exactly. Heavy computations, like complex Fourier analysis or large statistical correlations, are offloaded to the server, keeping the client side lightweight and responsive. Unity's primary role is to vividly visualize and allow intuitive interaction with the data, not to quench the complex numbers itself.
So Unity is the window, the server does the heavy lifting.
Precisely. This separation of duties ensures a fluid, immersive experience for the user.
This careful architecture allows for truly advanced visualizations that deepen understanding, making the invisible forces of space visible and tangible.
Seeing the unseen.
One of the most compelling visualizations will undoubtedly be Earth's magnetosphere. It will be represented as a semi-transparent mesh or glowing field lines swirling around a realistic Earth model, changing shape in real time in direct response to solar wind pressure.
You can actually see the solar wind hitting the shield.
That's the idea. To truly make the invisible visible, these changes in the magnetosphere will be visually exaggerated. For example, you'll see dramatic compression during a strong solar wind hit, with magnetic field lines fluttering or glowing intensely during geomagnetic storms.
Making it obvious what's happening.
Their color will even be modulated by the interplanetary magnetic field's BES component, which indicates the direction of the magnetic field carried by the solar wind, a crucial factor in geomagnetic activity.
Showing the polarity, okay.
You'll also be able to see color-coded world maps showing the probabilities of auroral visibility at various locations, complete with real-time KP index values, giving you a live read on auroral strength and where to potentially witness those incredible light shows.
A real-time aurora forecast map in VR.
Nice. Beyond that, the system will offer incredibly interactive 3D and even 4D visualizations, meaning it incorporates the element of time.
4D time is a dimension.
You'll be able to see geophysical and geological data. Imagine seeing a realistic Earth model overlaid with fault lines and tectonic plates, with flashing dots indicating real-time seismic activity.
Live earthquake tracking on the globe.
You'll also see visual representations of tidal bulges from the moon's gravity, highlighting stress on fault lines, dynamically showing how Earth's crust is responding to both internal and external forces.
Visualizing tectonic stress. That's useful.
And you'll also visualize atmospheric and ionospheric data, with layers of the atmosphere responding to incoming solar radiation, showing how it impacts ionospheric density and creates electrical currents.
Watching the ionosphere react.
Interactive 3D models will display real-time data feeds and possibly predictive analytics for volcanic risks, allowing you to see where and when eruptions might occur.
Volcanic prediction too. Ambitious.
To make complex, subtle interactions understandable, the system will feature exaggerated scales and a level of detail, or load scaler.
A level of detail scaler.
This innovative tool allows dynamic adjustment of visual parameters like force magnitude, density, motion, frequency, color, and even charge, all based on your input and the data's inherent complexity.
So you can zoom in on the details or pull back for the big picture.
Exactly. This means you can zoom in on concepts, shifting seamlessly from a high-level overview to incredibly nuanced details, catering to everyone from a curious student just starting their journey to a seasoned researcher seeking deep insights.
Truly a personalized learning experience.
This isn't just about displaying data. The hub will leverage powerful AI for automated content generation, making the information even more accessible and tailored.
AI writing the news reports.
Sort of. Each morning, the system runs an automated data summary job, aggregating the last 24 hours of critical data, for example, the highest solar wind speed recorded, or any notable earthquakes or solar flares.
Okay, digest the key events.
This summary then intelligently prompts a large language model to write a full 10-minute script, including a warm greeting, the main stories on solar, geospace, and earthquake events, and a concise forecast, all tailored to a general public with an enthusiastic, engaging tone.
A daily AI-generated space weather briefing.
But a critical point here, and one that ensures accuracy and quality, is that human editors rigorously review and correct these AI-generated scripts before they go live.
Human oversight. Very important.
Absolutely. Once approved, the system automatically triggers text-to-speech, or TTS, services to generate realistic voice audio, renders updated charts and images, and prepares optimized 3D scenes.
The full multimedia package.
All of this content is then packaged into asset bundles for dynamic, on-demand download by users, ensuring a fresh and relevant experience every day.
One of the most powerful features of this AI integration is its educational customization, using large language models to tailor content for vastly different age groups and levels of expertise.
Tailored explanation.
Exactly. The AI dynamically adjusts its vocabulary and depth. For example, for younger audiences, it might describe a solar flare as, "The sun burped out some plasma," a simple and relatable image. Okay, for experts, it would provide a precise scientific description. An X-class solar flare occurred, causing a CME traveling at 1,000 kilometers.
Adapting to the audience.
You, the user, have control too. You can even press an Explain in Simpler Terms button for real-time rephrasing of complex concepts.
Instant simplification. Useful.
Beyond language and age, content can be customized to regional interests and cultural context. For an Indian audience, for instance, it might focus on how space weather impacts their extensive rail network or monsoon prediction technology.
Making it locally relevant.
Conversely, a North American audience might learn about its impact on power grids. The AI can also insert relevant comparisons, referencing local historical events like the Carrington Event auroras, which were visible in India in 1859, or the Quebec blackout in 1989 for North America.
Making the information immediately relatable and impactful for users worldwide.
The hub also incorporates an incredibly intelligent, sentiment-informed early warning system that goes beyond just raw sensor data.
Sentiment-informed, it reads social media.
It actively monitors sources like social media and news articles for public reactions to space weather events. By feeding posts into a sophisticated sentiment analysis model, the system can detect patterns of panic, widespread concern, or the spread of misinformation trending around an event.
Like fear about GPS outages after a flare.
Exactly. And this information can then be flagged to human editors or even automatically trigger the insertion of clarifying, debunking segments into the content.
Fighting misinformation in real time.
Our sources also detail the design of sophisticated LLM controllers, which are akin to advanced AI orchestrators. They act as function definers and function callers, essentially defining and executing tasks for other AI agents.
AI managing other AIs.
Crucially, all AI agents involved undergo a discovery process, with a human in the loop, who provides continuous feedback to generate and refine their functions, ensuring their quality and relevance. The function caller is then trained through various scenarios to effectively organize the sequence of function calls and actions.
Human guiding the AI team.
These agents and the function caller continuously adapt based on this human feedback, refining their functions and call sequences over time. This multi-agent system has broad, transformative applications beyond space weather.
Like what?
Including a virtual integrated care system for aged care and dementia, with specialized caregiver, therapist, and health analyst agents. It could also revolutionize education and lifelong learning, creating personalized learning plans and rapidly upskilling educators in AI.
Wow, wide applications.
And critically, it can be used for disaster prevention and recovery by modeling climate impact and planning highly optimized response strategies.
Now, let's step into the ultimate visualization experience. The Space Weather News Hub is centered around an incredible cosmic-themed VR studio designed for complete immersion.
The VR Studio. Paint a picture.
Imagine interactive 3D models of celestial bodies, dynamic ambient lighting that shifts with the cosmic data, realistic textures, and spatial audio that truly envelops you for an unparalleled experience.
Sounds immersive.
Within this environment, interactive elements are intuitive, including touch-enabled controls, object selection, and dynamic menus with sliders for data manipulation. The user interface for data manipulation in VR allows you to interact with and control the visualization of data directly, feeling like you are truly shaping the cosmos.
Hands-on data interaction.
What's particularly fascinating here is a unique conceptual data architecture system described. It uses various conceptual layers or planes, represented visually by 7 nested tori or donut shapes, each with distinct colors.
7 nested donuts.
This system sets up interior personal view and exterior observer view for each torus, allowing abstract data to be mapped onto these structures. This makes complex, multidimensional data intuitively understandable.
A novel way to visualize complex data.
A robust VR interaction system handles all your inputs, especially for high-fidelity Vive Pro users, enabling precise selection, manipulation, and menu interaction. And there's even a pinning system that allows you to pin your favorite interaction sequences or data views within the virtual space for quick access and replay, creating a personalized learning dashboard in 3D.
Saving your favorite views. Smart.
Beyond the Cosmos, our sources outline pseudocode, a high-level description of an algorithm for simulating life-stage agents.
Life-stage agents, like AI people.
Think of these as incredibly realistic AI models of human beings at different developmental stages, such as toddler, child, or teenager. These agents are defined with specific attributes, like language acquisition capabilities, evolving cognitive skills, and behaviors, such as imitation learning or complex problem-solving.
Simulating human development.
The simulation sets parameters for token allocation, which influences their processing power, efficiency factors, and complexity multipliers, reflecting how quickly they learn and adapt. It includes dynamic components like time allocation functions based on age, daily activities, developmental stages, and external influences.
Simulating a whole life experience.
Essentially simulating an entire life experience. It even incorporates base and expanded formulas for calculating thoughts per minute and words spoken per minute for these agents, offering an unprecedented level of behavioral detail.
Thoughts per minute, that's detailed.
This intricate simulation, integrating various submodels like cognitive development and physical activity, is designed not just for abstract research, but for highly practical applications. Training experts in diverse fields by realistically simulating complex human behaviors and interactions across different life stages.
So, training doctors or teachers with virtual people.
Imagine training disaster responders by simulating the behaviors of a panicked crowd, or educators by interacting with realistic virtual students, allowing for highly nuanced and effective training scenarios.
That could be incredibly valuable.
And finally, our sources reveal a grand, long-term vision for humanity's resilience, self-sustaining super eco-subterranean cities.
Underground cities, like sci-fi.
These aren't just bunkers. They're designed as complete eco-civilizations, capable of recreating surface ecosystems and functioning as biosphere reserves in case of global disasters, including cosmic ones.
Full ecosystems underground.
These visionary cities feature fully AI-managed food production, comprehensive waste management, optimized energy use, and meticulous cultural data preservation, ensuring humanity's knowledge and heritage endure.
AI running the city.
They also boast AI-powered climate control systems that precisely mimic surface ecosystems and provide robust protection against cosmic threats like solar micronovas.
Protection from the micronova.
That's the idea. Crucially, models and simulations are being developed for scaling energy needs, allowing for a seamless transition between Kardashev levels from a planetary Type I civilization, using all-planet energy, to a stellar Type II, using all-star energy.
Scaling up civilization's power usage.
Based on real-time energy demands, urgency, and the magnitude of cosmic or environmental threats. What's truly fascinating here, and perhaps surprising, is that these subterranean facilities aren't just theoretical constructs for the distant future.
They exist now.
Our sources suggest that there are already hundreds of thousands worldwide, potentially capable of housing millions of people and months of supplies.
Hundreds of thousands, really.
They offer a tangible pathway to a pre-industrial reality for survival, providing shelter from cosmic rays, harmful UV radiation, and severe electrical disruptions. It's a vision of deep resilience, ensuring humanity's future even in the face of the most profound cosmic events.
A hidden layer of preparation.
We've journeyed today through an intricate cosmic dance, from the energetic whispers of our own sun to the profound and rhythmic influences emanating from the vast galaxy beyond.
It's been quite the trip.
We've seen how ancient insights and forgotten wisdom are finding surprising, robust confirmation in cutting-edge modern science.
The old meeting the new.
And how revolutionary technologies like advanced AI and immersive VR are providing unprecedented tools to understand, visualize, and even strategically plan and prepare for these grand, cyclical cosmic events.
What's truly fascinating here, and perhaps the most important takeaway, is how these massive, seemingly distant forces have a direct, measurable, and often surprising impact on you, on our planet's climate, on its geology, and even on our very physiology and psychology.
It's all connected.
deeply. This deep dive has shown us that our existence is far more entangled with the cosmos than previously understood, demanding entirely new ways of thinking and new, powerful tools for exploration and adaptation.
So what does this all mean for you as you navigate this incredible unfolding cosmic story? As Earth's magnetic field continues its undeniable shift, and with the revelations about the cyclical, powerful nature of cosmic events,
Where do we go from here?
perhaps the ultimate preparation isn't just about physical survival or building resilience. It's about cultivating a deeper, more profound understanding of our true place in this dynamic electric cosmos.
Understanding our connection.
Consider the profound, almost magical power of your own mind, as our sources suggest, in shaping your experience of these changes. What hidden connections might you discover in your own daily life and your own observations that reflect these larger, majestic cosmic patterns? The universe is constantly speaking to us. Sometimes we just need to learn how to listen.
Minjeriba, neon strands, thorium power in my sense. Orombo winds, lunar tides, Dakini codes, goddess rise. Neon glow, soul secret code, united we thrive. Raise the vibe, sun and sand, tide and wave, power up, cosmic rave, civilization of sand, solar prophecy hand in hand. Neo's magnets and monazite finds, quantum mantra, silicone mines, titanium shell, thorium core, clean and safe for sure. Breathe, hold, expand, release. Yogini ignite, feel the heat. Malone bus cliffs, sunrise complete. Kardashev 1, sparks ignite, titanium sands, neon lights, Dakini pulse, love on the winds, thorium sands, clean nuclear trends, quantum echoes, kiss my lips, micronova, heat wave grips, sacred sands, sacred lore, binary tantra, open the door. Gatra earth unlocks in time, tantric circuit, the pulse divine, solar memory, data combined, encoded prophecy. Is it almost time? Waves push and pull, tides rise and fall, sacred myth, comprehend it all. Super intelligence just in time, clean green energy for a dime, quantum moments, stellar design, Dakini souls, hearts divine.